One of the most important skills when we're dealing with multiple equations is knowing how to solve for each variable. This can be very important because in the real world we often have multiple equations to satisfy. Sometimes 3, 4, 5, even millions of equations. Today, right in this problem, for right now, we're going to go over section 11.1, problem 12. That's on page 781. We're going to do this by both substitution and elimination methods. For substitution, we solve one of the equations for a certain variable and plug it into the other equation. In this case, we start off with t equals 5u plus 6 and t equals 5u minus 4. So we've already solved for t. So in this case, I write out 5u plus 6 equals t, which is 7u minus 4. I can now solve this equation for u. I will subtract 5 from each side. This leaves me with 6 equals 2u minus 4. I will then add 4 to each side. I'm left with 10 equals 2u. Divide each side by 2. 5 equals u. Given we know this, we take this, plug it back into our original equation, and solve for t. So 5u plus 6 equals t. 5 times 5 plus 6 equals 31. T equals 31. Now, this will also work for using multiple equations. If we had 3 equations, we could have solved for t and plugged 7u minus 4 into each of those. We would have then ended up with a system of 1 fewer equations. And we could have continued our method until we only had 1 variable, in which case we could solve for it. We just did substitution. Now I'm going to do elimination. Elimination is very straightforward. We want to write our equations in such a way that we can subtract one from the other. In this case, I'm going to subtract the bottom equation. So I'm going to multiply it times negative 1. You get a negative t, negative 5u. Our plus 6 becomes a minus 6. Now, we add these together, we get 0 plus 2u minus 10, which is 10 equals 2u, which is 5 equals u. Once again, we can take this, plug it into our original equation, and get 7u minus 4 equals t. 7 times 5 minus 4 equals 31. T equals 31. Either of these methods may be used for as many equations as necessary. However, when we're dealing with large numbers of linear equations, we'll find that using matrix methods makes it even easier.